Hi, my name's Mason, and I'm going to be the disembodied voice throughout the entire thing. I'm going to talk through what we're doing in the video, and I'm a lab partner with Harbin Tinney. He did most of the lab work. I'm going to do most of the editing and voiceovers. So, what we're doing is we're going to plate zinc onto copper with a solution, and that's going to be zinc chloride. We're going to use 0.1 milliliters of 1 molar zinc chloride, and we're going to, and some granule zinc at the bottom of the beaker. We're going to set pennies in. That's going to be at a low boil. That turned out to be about 300 degrees Celsius. And we are going to put those pennies in. They're going to get plated with zinc. We're going to take them out and we're going to heat them up on both sides, and that's going to form brass alloy on the edges. I'm going to go through that more thoroughly later, but for now, we can't get to the experiment quite yet. What we got to do, actually, is we have to get the copper oxide off the pennies. So what we're going to do is I'm going to explain that more later, but we're going to clean off the pennies. We're going to clean off the copper oxide on the pennies, so that reveals a layer so that zinc can plate onto it properly, and we'll get some really good turnouts. All right, so it's May 12th, and I'm just here to discuss the pre-preparations for the lab that we're doing and you're watching the video on. My dogs are just let out. Hopefully they do not create any noise. So we have pennies, and as discussed earlier, we're going to turn these pennies into brass alloy. And we need good pennies. Those aren't good pennies. So we're gonna need to fix that. And how we're gonna do that is we're gonna take vinegar, which is an acid, and put it with salt and put these pennies in that solution. That's gonna react to the copper oxide. This is the worst of the pennies that we have. You can clearly see, I don't know how well you can see that on the camera though. You can see the bluish copper oxide on this. This is going to be cleaned off by that vinegar. It's going to react with this copper oxide. It's going to clean it off, and it's going to make it all shiny again. We need to do this because that copper oxide takes up space. It's covering what we want to actually react. So when that actually reacts, we're going to have a full penny, clean penny. So we're going to clean off this copper oxide with that vinegar solution, and I'll come back to you when it's done, and I'll show you the finished product. Oh, I got to move back a little bit. So, I lied. I'm going to actually show you the prop of what I'm doing. So, I'm not an expert penny cleaner, so I had to look up what I had to do. So, I'm mixing 2 teaspoons of salt with a half cup of vinegar, and we're going to put it in this glass cup, and then we're going to clean it with water, which is not present at the moment. This will take about 15 minutes. I'll put a time lapse of it in the video if it turns out good. Hopefully it does. I kind of want to see that too. I might zoom into pennies during the video. I don't know. We'll see. But right now I'm going to set this up. I don't know how bad my headache's going to get because of this vinegar, but we're going to find out. So, currently we're adding the zinc into the beaker. We've already pre-prepared the zinc chloride at 1 molar. So, now we're going to move and change the position here. I'm going to drop the pennies in before I add the zinc chloride. I probably should have heated up the solution before I did this. Honestly, this was a bad move on me. What you probably should have done here is waited for the solution to heat up and then add the pennies. Now, this was just me being stupid, I guess. So we're going to add the zinc chloride, and then we're going to heat it up.
So now we're going to put this solution with the pennies and zinc onto the preheated hot plate. And this one's preheated to about 225 degrees. So what we're going to do is we're going to fast forward, and eventually we do push it up to around 325 degrees. This is in Celsius, by the way. This was just me trying to be careful. There's no real instructions online, so like about what temperature it should be. It just said low boil, so we kind of played around with the temperature and kind of freehanded it from here. So now we're going to have ourselves a little intermission. I'm going to talk about some of the stuff and how we did this. See you there.
Thanks, Disembodied Voice. Great transition.
Thanks, Mason.
All right, let's get down to it. So, 1, we're going to cover what we actually made. 2, we're going to cover we did 2 different experiments, and we're going to cover the differences and why I prefer one over the other. And 3, I'm going to kind of say a fun fact if we have time. Probably will have time. So, first, we're making brass. Now, brass is an interstitial alloy formed with zinc and copper. If you take a look at the periodic table, they're right next to each other. Form a nice little perfect interstitial alloy. So, that alloy looks golden. So, how do you make an alloy? Well, 1, you need 2 ingredients. You need both of your interstitial next to each other on the periodic table. So they got to be able to make an interstitial alloy. 2, you got to have them close enough together. So that's what the process we were doing right a little earlier. That was getting zinc to be plated onto the copper. It's not replacing the copper, it's being plated onto it. So it's kind of binding itself to it. Now, that gets it close enough to when we take it out, cool it down, wash off some of the excess zinc, and heat it up again, but not in the solution. We heat it up. That will push the zinc kind of in, and then it's going to start shoving copper out of the way. And it's going to create an interstitial alloy called brass. That will give it a golden color. Like tubas, they have that kind of shiny golden color. And so, alloys used all over the world. Uncountable uses for them. They are very versatile, and you can make a lot of things out of them. If you don't like the properties of one thing, put it with another. Make an alloy. It's got different properties. So, there's a lot of uses for alloys, and brass is kind of versatile. It's malleable. It's very easy to bend into the shape of instruments. It doesn't rust, so that's also good for instruments as well. Brass can also make things look golden. It's used for personal. And yeah, I mean, alloys are used all over the world. There's steel, there's brass. Those are the only 2 I have off the top of my head. So, let's go on to the next part of this. The 2 experiments we did. We actually have 2 separate footages. You've only seen 1, and that's the one we actually like the most. Now, 1 we used sodium hydroxide, which is not a very fun chemical to work with. If you ever heard of strong base, it melts through your skin. Not entirely, but it does destroy your skin, and it's not fun to work with. Next, we have zinc chloride. It's not nearly as safe as water is, but it's still safer than hydrochloric acid, or has sodium hydroxide, excuse me. Now, originally, people thought that copper was the oxidizer in this reaction and zinc was the reducer in this reaction. So you needed sodium hydroxide to hydrolyze zinc, and then it would become a reducing agent, and then it would reduce and plate onto the copper, and copper would be kicked out of the solution. In that experiment, we saw the solution turn like it's got dirt in it and stuff like that. It's probably the copper being pushed out of solution and then falling out of solution because it's not soluble. It's heavy metal. Now, the other experiment is under the assumption that zinc is both the oxidizer and reducer in its own reaction. Now, that holds true. People in 1995 actually tested it and proved it. The previous half reactions look like this. And now, since zinc is now its oxidizer and reducer, it's much simpler. So all we have to do is heat up zinc chloride. So we have aqueous zinc. So we have zinc ions, and then we have solid zinc. So the solid zinc is going to come out of solution, and the zinc ions are going to go onto the penny. And there you go. That's your oxidizer and reducer. Can't say this enough. Zinc chloride is much safer than sodium hydroxide. Much easier to work with. Had a lot more fun in not worrying about dying and permanent scars working with zinc chloride. Much more recommend it. Flint Science has a great instructional video. I don't know how well they did. I did watch it. I didn't get too much out of it. So, and it looks like we don't have time, but I will say this: alchemists in the mid 13th century actually thought that they were doing alchemy with this and producing gold from copper. Turns out they're not. They're just making brass. And so I find that pretty cool. We have elements of redox reactions, some electrochem terms, and just some general understanding of chemistry and periodic trends in this experiment. And it's a good way to reflect that. And another way you could do this that's actually safer than both these methods, and I wish I did, was you could actually just electroplate this onto zinc, or onto the pennies. You can really just make a battery and just electroplate them, and it'd be much easier than any of what we just did. Prefer that, but I kind of liked working with the chemicals. It was very fun. We didn't get a chance to do it because of we didn't have time and COVID and blah, blah, blah. Just crazy stuff. So I'll do a little short end card because I kind of said all I wanted to say here, but I may want to say some closing terms, and that's about it. Enjoy the rest of the experiment.
You can see the final products right here, and huge thanks to our chemistry teacher who helped us a little bit and allowed us to use her lab.